This is an 86-year-old male who presented with dyspnea and heart failure, long history of heart failure, and also coronary artery disease, which was treated there with the right coronary artery PCI in another center. Next. The echocardiography or echo Doppler evaluation showed the severe aortic stenosis with an area of 0.6, a gradient of 64 and 36. He also had a tricuspid calcified valve with the left ventricular ejection fraction of 55. And this is the CT scan evaluation. He had a 23 by 26 in diameter annulus. The perimeter is 78 with an area of 480. Coronary height is 16 or close to 17 on the right. And on the left, ostium is at 11. So this is the annulus and also the sinus of Valsalva, which are 29 and 32 and 30. And this is the measurement of the annulus, which were already mentioned. Next. This is the LVOT, quite similar to the annulus, and the sinotubular junction with some calcification on the area of the right cuspid about the right coronary artery, which is important for predilatation. We are going to predilate, but with not too big balloon, just to try not to touch too much this area. Next. This is the ascending aorta, 20, I would say in average 30 millimeters in diameter. This is the calcification of the leaflets, especially the left coronary cusp is heavily calcified on the border. So we are going to predilate with a 20 millimeter balloon. Next. And this is the right and left cusp overlap position for working. It's going to be on the right 16 and caudal elongation of 18. So it's unacceptable and comfortable for operators. Next. And this is where we have problems. There's a heavy calcification of the abdominal aortic and also the bifurcation of the aorta, compromising both common iliac arteries and also some calcification on the common femoral arteries. And this is all the measurements which were done on the core lab. So this is a potential subclavian axis, a lot of calcification on the level of the aortic arc in the origin, and also it's not that big. And also tortuous, so it's not an option. Abdominal aortic is not an option for a transcaval approach. There's could be a possibility for transcarotid. We don't have experience with that. So we decided to proceed with our more experienced vascular access, which is the femoral. Next. Regarding the valve, the perimeter is in the range of the 29 with the 16% oversizing, which I think is okay for this heavily calcified valve. So we finally decided to go by the right because it was calcification. It was not on the anterior wall of the common femoral artery. We did crossover for protection. Next, we did an injection. As you can see there, both we use angio, echo, everything to have the best possible access on the area without calcium. There is a spot there where we don't have calcium. The needle try to go there. And here where we are, I think this is the last injection. Let me show you what we have here. We have a 7 French in the contralateral access. We have some bleeding because we have a catheter and also a wire, and so it's not the valve is not working perfect when you have two different things in the lumen. And then we have on the right side, after the ProStar, we introduce an 11 French sheath. So we are not going to have any kind of problem for the balloon. So my intention is all this area of calcification of the common at the bifurcation. We are trying not to use too much contrast. We are going to predilate with a 5.0 millimeter balloon, just to be sure that the balloon is not broken during the predilatation. And then we are going to change for the shockwave balloon. So this balloon is 7 millimeter on diameter. It has 5 measures, 1 centimeter between each one. And the energy is delivered through this metallic dot that you are going to see on fluoro. So it's very important, the previous preparation. It's very important not having any kind of bubbles, because if not, the energy is not properly delivered. Okay. Here you might see 1, 2, 3, 4, 5 dots, which are inside the distal and proximal marker of the balloon. These are the working area of the balloon. So my idea is to pull the sheath a little bit to apply energy here where we have calcification here. Let me show you with this, where we have the iliac bifurcation exactly there. So we will apply the energy from this dot, and this, and this, and this. So Dr. Fava is going to inflate the balloon at 4, but first we have to connect it here. Probably you can show you. We have prepared. You have to make here and here. And now the catheter is connected. There is a sound, which lets us know that it's ready. We have 100 pulses to be delivered. Dr. Carlos is going to inflate 4. There, no more. And I will deliver the energy. You will see some interference on the ACG, and also you can hear some noise here on the sheath. So now we have delivered 60, and now we are close to the 90s. We are going to deliver here more energy. So the discussion was also 6. Okay, deflate. Is if we have to deliver all the energy in the same place, or if the inflation of the balloon is okay and you decided not to go or to proceed with all the pulses that you have ready to go. Let's go. So Pancho suggests me to go with the full delivery, all the doses. We still have some resistance there, close to the bifurcation, so which is the area of more calcified, near the ostium of the common iliac artery. Deflate, Carlos, so I can move a little bit. Let's go again, inflate, 4. Okay, let's go again. We still have 180 pulses to delivery. We will save some ones to deliver near the bifurcation with the hypogastric. Once again, deflate. I'm going a little bit lower. Okay, here, let's go again, 4. Here is the external, which is 7 millimeters, but I don't want to go too high pressure here. So we'll keep it on 4. So after this, ablation or plaque preparation, I would say, we are going to exchange the wire. We will introduce a catheter through this O14 wire. We will put an extra stiff Amplatz wire to put the introducer set. If we have some problem, we can post-dilate with a 7 or 8 millimeter balloon. 6, deflate. Okay, let me see one answer. How is everything doing here? I think it's okay. Let's go with the last one. We still have resistance there. Resistance. I'm going to deliver again. I think it's okay. Okay, it's much better. Let me go there with the Lima or right or whatever, the Amplatz wire. Anyway, if for some specific reason, for example, let me know, heavily angulated aorta is more than 60, is out of the instruction for use of the core valve, the Evolut, and also for other self-expandable valves. So this is the situation where probably going with the balloon expandable would be a best option to be discussed. angulated aorta with bicuspid valves. It's also a situation where probably balloon expandable is the best option. Let me try to cross like this if I can. If you know, we prepare the Amplatz catheter. It's a very calcified valve. I don't know if I'm gonna be lucky. Okay, let's go. Pull the pigtail out. Okay, give me the Amplatz. Let's go to the conventional way. We have already prepared the confida with this very small distal tip angulation. Okay, let's go in the right view. Okay, here is when you advance the Amplatz, you have to pull the wire to prevent any ventricle damage. Give me the Amplatz wire. I will introduce a loop distal to protect left ventricle wall. And then I will introduce the pigtail. So now I'm gonna introduce the pigtail. We will measure the gradient. And then over the pigtail, I will introduce the confida wire. Then predilatation with a 20 millimeter balloon. Hold it hard. Tenelo fuerte. Okay. Bring the valve. So we are gonna check the loading of the valve. We are going to pace through the wire. So I think it's perfect there. Okay, thank you, Gabriel. Get back to the position. And now let's go with the balloon for predilatation, the 20 millimeter balloon. So vamos a 180, 180. Let's see, we don't have a good capture. Yes, now, yes, let's go. Let's go, let's go. Holding the groin, we'll pull the balloon. CG is almost the same. Now let's go with the valve. Carmen, estamos yendo. Okay, just to let Dr. Gomez know that we are ready.
Sí.
Yes. Okay, give me a test, puff, small. Let's go. Prepárate para 120. Very slowly, slowly. Now is the time to be patient. Okay. Okay, let's go. Let's go, let's go. Let's go. Okay, paralo. Stop. It's not, we have a lot of parallax there. Let's go on the left. I just focus on the non-coronary cusp. There I have 3-4 millimeters. Let's see on the left view. Move the table a little bit. Let's go a little bit cranial. So here, this, I think the position is okay. 2-3 millimeters on the non-coronary cusp. We have a good contact with the left. The right is a little bit upper, probably at 8 or something like this. I think we can deliver it here. We can release some pressure on the wire. We can keep it, everything almost free. And let's go pacing. 120. Please, let's go, Carlos. Slowly, very slowly. Test. Okay. Okay. Let's go. Okay. Now everything is released. Okay, let me pull the pigtail out. You see the position of the valve is okay there. It's at probably 3 on the non-coronary cusp. Now the catheter is out. We pull this catheter when we have calcification or significant or concentric calcification on the sinotubular junction. Now is the time for retrieving the delivery system. We still have some minutes. Here is when we use our shape of the wire, the second loop or second bend, sorry, to centralize the nose cone and to have a safe retrieval. It's a very mild paravalvular leak. So I think it's not necessary to use any kind of post dilatation. So this is the last injection. We have very mild paravalvular, which was shown by Dr. Mukarsel, 2 dots there. And when you can get back to the echo, you can see this dot at 2 o'clock. This is the mild paravalvular leak. Let me check the gradient. No gradient at all.
No gradient.
Could you show hemodynamic again? Perfect. When we have this supraventricular extrasystoles, the diastolic is a little bit low, but here is okay. So I think we are done. I will pull the pigtail, and then I will focus again on the iliac artery. So the TAVI procedure is done. No conduction disturbances so far. Give me the Amplatz wire again. Okay, perfect. I think we don't need a stand there.
No.
We have this notch, which was already mentioned. What we can do here is to measure the gradient. Give me the right, no, not the Lima, the right catheter or the Amplatz. Amplatz is okay. Yeah, this, perfect. So there, we have 2 significant calcification there. On the bifurcation of the common and external iliac artery, there is an indentation there, but not gradient at all. And then the notch of calcium on both ostium, but without gradient. So I think we are done. So we are going to close. Carmen is gonna revert hyperinization. Okay, what we probably can do, Carlos, is to close over the 6 French sheath. Just in case we have bleeding, we can use an extra angiosil as an adjunctive device for closing. So it's okay. So please hold it. Okay. I will put the 6 French sheath just to be sure we can enter with the angiosil in case we have bleeding in this complex scenario. So I am tightening. Be careful because I have problem here. Okay. Okay, let me know. Almost one is closed. So we will tie the second one and then we'll retrieve everything and we are done. Let me see, Kalona. You are crossed. Release. Okay. Hopefully you are watching there. I have to do this, not 1, 2, 3. Now, Carlos is gonna hold the thread. I have here inside the circle, and now I am pulling. Perfect. I think it's excellent due to the calcification. We are going to pull this and to put an angiosil on the 7 French, and the procedure is done.